Welcome to our channel. Welcome to our channel. My dad is the best teacher ever in his school. So
just talk. It's okay.
So we are going to teach you mathematics. Okay? Mathematics from my daddy.
The topic, tell them the topic.
The topic is longitude and latitude.
Correct.
So, follow this video step by step. When you skip it, you think about this mathematics.
So they should not skip them.
When you skip it, you will not understand. When you read a book, you will not understand what it means.
Okay.
So, follow this topic mathematics today or tomorrow.
Tell them welcome.
Welcome.
They should remember to do what?
You should remember, don't skip it. Subscribe it, share and like.
Very good. Unisaidie. So with me here, I have a crop. This crop has this circle, as you can see. There is this circle here. There is this. Like this, latitudes. All of them are unisaidie. Na hii sako iko hapa hivi. Na haka kasako kako hapa. Bottom hii ni ya kusimamia. The base. Atoshana? Asitoshana. Where we have the equator. The one that divides the globe to the lower hemisphere and the upper hemisphere. This is the equator of the earth. So if this one is small, so the equator above 0 knot, that is 1 knot, 2 knot to 90 knot, and any other below the equator, which is one more circles. This line you are saying that, so we are saying that this is the equator, and this line that goes like this, we call them latitudes. So these lines are called latitudes. And line that goes down like this, another one, this one itself, they are called longitudes, are great circles. All of them are great circles. All longitudes are great circles. It is only the equator that is a great circle. The equator is the only great circle among the latitudes, because the equator is our reference point. When we want to locate a point or a place on the globe, these are the lines we use. So, for example, place point A is on 50 north east, 50 degrees west. The first angle longitudes are measured here to the west is 180 degrees and it is west. From here to the east it is 180 degrees. The equator is 0. We have this down. The maximum latitude is 90. The maximum another down here 90 degrees north. This point A and B. So to do that, draw a sketch. Put in which we have 50 north is 0. So 50, this is north. 30 degrees east is on the right side. A is here. B. Point at P and B, 30 degrees north. So this is, remember, is the latitude. So the latitude we compare with the equator. So north, it is latitude we compare with the equator. So north, it is up. Up is up. Up the green, up the. So that is will be 40, 50 somewhere here. This one is 80 degrees north. And then is 80 degrees north. And then 70 degrees east. 70 degrees east, this is the longitude. The longitude, so 70 somewhere here. The longitude, so 70 somewhere here. We put it there. We put it there. This is the point B, so it means that point A is here. This is point A. Point B is here. This is point A. Point B is 30 degrees south. So this one tells us it is below the equator. So this is the equator. If it is the equator 0, south begins in here. If it is the equator 0, south begins in here, downwards. So it means downwards. So it means, right? Obtained will be here. Will be here. Great circle for a small circle. It is not detected. There is another there. Great circle for a small circle. It is not detected. There is another there. So small circle. It is not detected. There is another there. So their center is here. So their center is here. Yeah. That is now important. So distance along a great circle. So distance along a great circle. We can. So distance along a great circle. We can calculate the distance. I want to use this. For example, the distance from A to B is the arc length. The distance from A to B is the arc length of this point A and this one. How do we calculate the arc length A and this one? How do we calculate the arc length? That in Form 1, that in Form 1, even in Form 2. So arc length in Form 1, even in Form 2. So arc length 1, even in Form 2. So arc length over 360 to over 360 to pi 60 to pi r, where r is the r, where r is the z at the center of the earth This is how you calculate the greatest the distance along the great circle in kilometers. In nautical miles, the great circle in kilometers. In nautical miles, you just get the great circle in kilometers. In nautical miles, you just get it times 6. miles times 60 miles. Let us look at this example. The position of 2 points on the Earth's surface are A, 60 degrees south, point B along the Great Circle, point B along the Great Circle, in kilometers and in kilometers and in nautical miles. So let us now locate our point on the group. It is important that you sketch. So point A is important that you sketch. So point A is 4, right? Right? This is 40. This is the green meridian. So 45. So 45 west will be somewhere there. 5 west will be somewhere there. 45 degrees west. Point here is our point A. And then point B is 60 degrees south. 60. So view south 60. So view this is 40. 60 will be somewhere there. Same longitude 45. This one. So it means the point is here, right? So this is point B. So the center of B. So the center of this is here. So it will form this as the center. So what we want to form this as the center. So what we want, drawing a great circle, the pi r. R we have been given. The pi r. R we have been given. So how do we get the side, the south difference? So theta get the side, the south difference. So theta is 20. So times the radius 6370. And that one gives us the length AB, the arc length. And that one gives us the length AB, the arc length. Now calculate in nautical. I want to ask that one we know, and we know it is 6 cocanotes here. So parallel latitude angles, because they are alternate angle. And then all over 360. Now 360. Now I want to define what pi is, and we repair latitude there. Is the to define what pi is, and we repair latitude there. Is the angle difference, and theta is equal to the angle of the latitude. Latitude angle. Theta is the latitude angle, and the alpha is the angle difference between the 2 points. So our formula is here, miles, miles, distance, miles, distance, in a nautical mile, along a small times equals theta. Alpha remains the same, the angle difference. Theta remains the latitude angle. So this one is the latitude angle. So this one will give me distance along a small circle. So let us do an example. Points on the group. It is important you sketch. Let us sketch. A is 50 south. A is 50 south. South, this is the latitude, so it is below the, and then 35 degrees east, this is the longitude. So the longitude we count from the prime meridian. So, and this one is 35. We count from the prime meridian. So, and this one is 35 degrees east. And then point B is on the same latitude. To the west is west, so we are is on the same latitude. To the west is west, so we are going to the west, which is west, and this one is 80 degrees west. So because this one is a small circle, if it is a small circle, we will draw, the circle will be like this. A is here, P is here. So this is our, so let us get the angle difference. So from west 80 to 0, that is 80, plus from 0 to 35 and 15 degrees. And the angle difference is what we call alpha. So now we have 115 over 360 times 2 times 22 over 7 times r, 360, 370, always imepeanwa hivyo, times cos latitude. The latitude here, the latitude here is, you can see it is 50. So this, you can see it is 50. So this one gives us the distance along AB in kilometers, which is 822 kilometers. The formula 60 alpha cos theta. 60 is a constant times alpha. Our alpha is 115 times this one is cos 50, and this one will give 35 nautical miles. So that's how you calculate the distance along a small circle and a great circle. At an angle of 360, one revolution ikisunguka mara moja ina cover 360 degrees, and this one takes 24 hours a day. It takes 24 hours. So let us find what will. So we know that 1 hour is equal to 60 minutes. So if 60 minutes is equal to 15 degrees, what will it be 1 degree? What will be the time for 1 degree? So it is 1 times 60 divided by 15, and this one gives us 4 minutes. So for every change of 1 degree along the longitudes, there is a change in time of 4 minutes. Every time 1 degree changes from 1 to 2 degrees, there is a change in time either to the west or to the east. So this is the green meridian, and this is 0. To the east, this one is east and the west. The time to the west is behind the time on the east. The time on the east is always ahead. The time to the east is ahead. The time to the west is behind. So we look at that. So it means that for every 1 degree time of 4 minutes, very important. So we are going to use this relationship to calculate the time at given points or at given places. For example, find the local time in Nairobi, 1 degree south, 37 east, when the local time in Mandela, you should make to, and remember, for time, we are considering only the longitude, so we don't care about the latitude. We are interested in the longitudes, because we have said the change in the latitude, in the longitude, not latitude. We want to change the angle change in the latitude. So the angle change, the angle difference in longitude is, as you can see there, east, so it is 42 minus 37, and this one gives us 5 degrees. But we know that 1 degree is equal to 4 minutes. So now we want to find out the difference in time. You will ask 5 degrees will be what? This one will give us 20 minutes. But as you can see, Nairobi is 37 east, and then Mandera is 42 east, meaning that Mandera is ahead of Nairobi. So for us to get the time in Nairobi, which is behind Mandera, the time, we are going to subtract the time, because Nairobi is behind 37. It is where it is on the west, is on the Nairobi is on the east of Mandera. So if in Mandera it is 3 p.m., then Nairobi will be 20 minutes behind. So Nairobi will be 2:40 p.m. If we were getting ahead of Mandera, we were to add the time. This 20 minutes, we add that this one will repeat it 20 if it is in ahead of Mandera, or to the east of Mandera. If, for example, it was 50 degrees east. If the local time in town P 60 degrees north, 5 east north is M of town Q 60 degrees north, 120 west. So the angle difference along the longitudes is 120. Remember, we have 120 west and then 50 east. So it's 120 east to the green meridian, which is 0, and then from 0 to 50. So that's why we are going to add 120. 1 degrees is equal to 4 minutes. What about 170 degrees? So it will be 170 times 4 divided by 1, and this one will give us 680 minutes. So we convert this minutes to hours. You will find it is 11 hours 20 minutes. When you convert it, you will have 11 hours 20 minutes. But we are looking for the time to the west. The question asked time, a local time in town Q, which is in the west, 12 west. From east to the west, we subtract the time. So the time there is 2:30 p.m. Now we are supposed to subtract into 24 hours. So that one will be 14:30 hours, right? And then we will subtract 20. This one will be 10. 4 minus this one will be 3. So remember, this was PM. So this one most probably is AM. So the answer is tisa asubuhi, 3:10 AM, and that is the time in point Q. In place Q, the time is 3:10. You subtract if the time asked is to the west. We know that speed is measured in knots or in kilometers per hour. So speed measured in kilometers, it is given in speed is equal to distance divided by time. So this one, if distance is in kilometers divided by time, it will give us kilometers per hour. So speed in knots, you must have distance in nautical miles, and then divided by time to get the answer in knots. That is the only thing you need to know. So for us to get the speed, first we must calculate the distance. We have learned how to calculate the distance. So it is your duty to identify whether the distance you are being asked is along the great circle or a small circle. And then once you get the distance, you divide by the time you are given, you get the speed. An object moves from 30 degrees north, 0 degrees to 30 degrees north, 45 degrees east in 3 hours. calculate the speed of the object in kilometers per hour, and B in knots. So like I have said, first we must get the distance, and then we have time, we will get the speed as simple as that. So first we want to know, is this a small circle or a great circle? How do you know? This one is a small circle because the latitude is 30. So 30 is a small circle because we said all latitudes are small circles except the equator, which is 0 degrees. So let us get the angle difference. So the angle difference will be 45, 0, that one is 45 degrees. That is the angle difference, and this one is the alpha. How do we get the distance in kilometers along a small circle? We know the formula, it is alpha over 362 pi r cos theta. Our alpha is the angle difference, so we have 45 over 360 times 2 times 22 over 7 times 6370 cos latitude. The latitude is 30, cos 30. This one will give us the distance as 43.6 kilometers. Equal to distance over time. Our speed is our distance is 334.46, and our time is 3 hours. So we are going to have now the speed, and our speed is, we divide by time, which will give us 144.82 kilometers per hour, and this one is the speed. So you see, you need to calculate the distance first. Part B, we are supposed to calculate in knots. For you to calculate the speed in knots, we must have distance in nautical miles. We must have distance in nautical miles. But we know distance in nautical miles is given by 60 alpha cos theta. We have 60, which is 60 is a constant, times alpha, which is 45, times cos 30. And this one gives us 2338.27 nautical miles. So speed in knots is equal to distance in nautical miles divided by time, and that one is 2338.27. we divide by 3 hours, and this one will give us 779.42 knots.